processing, and that got captured and electrolyzed and so forth. But through gas chromatography, we had a range of 2 to 8% oxygen production, which compares very well to the 1% oxygen reduction from hydrogen reduction. Next slide, please. And the methanation reactor results there. This reactor is very efficient, anywhere from 99 to 100% conversion in a single pass of the carbon dioxide to methane. I'm sorry?
You got 10 minutes.
That's all right.
You have 10 minutes.
Seriously? 8. Oh, okay.
Yeah, I had misread as a 7 instead.
Okay, great.
But you got 7.
But anyway, the upshot of that is just that it's a very efficient system. Next slide. And there's a gas scrubber because the gas coming off the system, we can't afford for that to contaminate our catalyst. And this was supplied by Eddie Santiago at Kennedy Space Center. And it did very well in terms of removing the fluorine and chlorine and sulfate that is generated in the process of heating up that material and reducing down to parts per million range. Next slide, please. And the system was sealed very well. We had very low leak rate. In fact, it got better. I think they found a few small leaks after the first day, and I got those fixed. But anyway, personal. Yeah. So this is what the solar power looked like for one of the runs. And so you turn it on, and it shoots up into the 500, 600 watts range. And as the system tracks the sunlight across the sky, so when it's lower in the sky, you can get less energy because there's more atmosphere. If a cloud or a haze drifts by, that will cause these dips you see. Next slide.
Assuming a Mars environment, how much of the solar efficiency is going to be affected by 1.6 AU?
Well, it's going to be tougher on Mars to collect solar energy. If it's now, the one thing that's dramatic about the solar collector is that even if you have just a high cirrus cloud, it diffuses and you lose just about all of it. The melting stops. So it's sensitive to that. On Mars, we may want to consider a different energy source, more like just a solar cell, which it doesn't care much about what the direction the sunlight comes from, and just use electricity.
On Mars.
Okay.
Can we wait for questions till the end?
And here's the temperature as a function of time here, and the quartz rod, which is used to deliver the sunlight to the surface, is movable up and down to adjust for different sunlight power. And so that green line shows you how far it was, minimum of 3 centimeters away, to try to keep the temperature fairly constant. Next slide, please. And so that's what it looks like when you add both the solar power and the temperature. They track fairly well. I don't know why even though it went down, the temperature went up a little bit. That one throws me. Next slide. So we've demonstrated a closed loop operation of the Carbothermal system using direct solar energy at an analog test site. Ran for 10 days with multiple batches per day. We got up to 8% oxygen out of the system and 10% total based on the water. We removed the contaminants down to less than 1 part per million. Got almost virtually 100% one-pass conversion efficiency, and everything worked out in terms of sealing and so forth, even in the dusty environment. Next slide, please. There's this thing called carbon cap formation. That is, if the temperature drops off, but you don't slow down the methane, the carbon may gather at the top of the system, and it takes a while for that to react because it looks like apparently it gets a little separation. It also tends to insulate the regolith below it. It's not as hot, and so it doesn't react as quickly. So that's a touchy little issue. The quartz rod is something we need to keep away because there's a little splatter. We have a quartz window that we put in front of it to help protect it. But we would like to be able to get further away with a higher power source. As I mentioned, solar flux theory, We were working at a solar power simulator that will be used to simulate sunlight on the moon without the clouds and so forth. And let's see, so there are other heat sources that we're looking at. And,
5 minutes.
okay, and then Orbitech also has another contract right now looking at alternatives to this process using coated heating elements and crucibles instead of using the regolith itself as the container, something that will stand up to the molten panel. Next slide, please. Okay, so this is a little out of date. We're not going to be able to do all that because the laser diodes were damaged in shipment, so we're going to put that off until after October 1st. But we'll go out and figure out how well things work with these laser diodes to get us up to a kilowatt of power instead of only 700 watts. And then we're also going to look at doing multi-melts in order to start doing the scaling up so that we can do more than one at a time. And anything else? Next slide. So we did good, and the system performed very well. We were very happy with that. Did the best to thrust, and Orbitech did a fantastic job there. Anything else? Oh, yeah. And this was through a Phase 3 SBIR contract from NASA Kennedy. I think that's it.